All right, we're going to look at 7.5, where we're going to revisit the product rule on radicals, and we're going to finish the simplification rules on radicals. So the first thing it looks like we're going to do is distribute. So we need to revisit when we can use the product rule on radicals. You can take the nth root of a times the nth root of b, and you'll get the nth root of ab. So you can multiply radicals together when their index is the same. You multiply the radicands, remember that's what's underneath, together. But this is only allowed if each of these expressions actually represents a computable real value. So when we look at our first one here, we're going to distribute. So we're going to take the square root of 3 times the square root of 15, and we'll get the square root of 45. And then we'll keep distributing. Square root of 3 to square root of 7, we'll get the square root of 21. Now, as we've already learned, radicals must be in simplest form. So it says multiply and then simplify each product. So we need to think about 45. Is there a perfect square that goes into 45 to simplify it? So we would say 9 times 5 minus, there is no perfect square in 21, so that one's finished. So we're going to take square root of 9 is 3, square roots of 5 minus the square root of 21. So first off, multiplication means to remove parentheses. Radicals need to be simplified, and then you need to check like terms. For addition or subtraction, remember, like terms means identical, same radical expression. So these are not the same. So we are finished with our multiplying and simplifying. Here, to do this one correctly, we're going to write it twice. So we're going to say 5 square roots of x plus 3 times 5 square roots of x plus 3. We then use the FOIL method. So 5 square roots of x times 5 square roots of x, you multiply the 5's together for 25. And then square root of x times square root of x is the square root of x squared, because the rule is you keep the same index and you multiply the radicands together. That was the first part of FOIL. Now we're going to go to the outside part of FOIL and say plus 15 square roots of x. Then we're going to come inside and get another 15 square roots of x, and then 3 times 3 is 9. Now this one here, the inside power matches the outside index, so we need to take 2 into 2 and say this becomes x. So we get 25x plus, these are like terms, so we add for 30 square roots of x plus 9. And there is our answer. If we're going to do problem 3, we're going to FOIL also. It's a cube root times a cube root, so we get 2 cube roots of 25 minus 3 cube roots of 5 plus 16 cube roots of 5 minus 24. Cube root would be needing 3 of the same to simplify, so this is done. So we just recopy 2 cube roots of 25. These here are like terms because they share the same identical cube root of 5, so we get to combine to plus 13 cube roots of 5 minus 24. And there's our answer. Number 4 also uses FOIL, so square root of 2 times square root of 6 is the square root of 12 plus the square root of 10 minus the square root of 18 minus the square root of 15. Some of these have perfect squares that make up their number. So for example, 12 could be thought of as 4 times 3. Square root of 10 has no perfect squares. 18 is 9 times 2, and the square root of 15 has no perfect squares. So 2 of these radicals need to be simplified. This first one becomes 2 square roots of 3 plus the square root of 10 minus 3 square roots of 2 minus the square root of 15. Now if we look across, none of these radical expressions are identical, so we have no like terms, so we are finished with our work. 5 more FOIL, so 2 square roots of x times 4 square roots of x, multiply the coefficients, 8, Square root of x times square root of x, this is square root of x squared. Now we're going to continue FOILing, so we get minus 2 square roots of x, minus 12 square roots of x, 3 and 4, and then a negative to a negative is a positive 3. Right here, this needs to be simplified to x, so we get 8x. That's because 2 goes into itself once. These are like terms, so we get minus 14 square roots of x plus 3. To finish 6, we FOIL one more time. So we have 7 times 7 is 49. Minus 7 sixth root of 15. Come on the inside, plus 7 sixth root of 15. Minus the sixth root of 15 times 15, which is 225. Remember, multiplying radicals, you must have the same index, and you keep that same index and you multiply the numbers together. So we take 15 times 15. Now these right here are like terms and carrying opposite signs, so they cancel each other out. So we're left with 49 minus the sixth root of 225. The next part of 7.5 is going to work on the final piece of criteria to say that a radical expression is fully simplified. So we're going to talk about how to clear a radical from the denominator. This idea is better known as rationalizing the denominator. So here's how we do this. If we want to simplify or rationalize the denominator, the first step is use the quotient rule to write two radical expressions. Then simplify each radical to lowest terms. And then rationalize the radical expression from the denominator. Sometimes all those steps are necessary, sometimes only some. So we can see on the first one, the only place I see a radical is in the denominator. So I don't need to write radicals across the fraction. And I cannot simplify the square root of 3, but I need to clear it out. So here's how you clear out a square root. You multiply it by itself. So when we take the square root of 3 times the square root of 3, we get 3. Another way to think about this is the square root of 9, because the product rule says multiply the numbers together. And the square root of 9 becomes 3. Then the top is 24 square roots of 3, it's written side by side, because remember, whatever you do to the bottom of a fraction, you must do to the top. Now 24 over 3 as a fraction reduces, so we get 8 square roots of 3 as our answer. So this is a fine simplified answer. When we move on to 2, we must first write the square root of 3 over the square root of 2. Now the only place that the square root is not allowed is in the denominator. So it's the square root of 2 that we need to rationalize. So every time you want to rationalize a square root, you multiply it by itself. So square root of 3 times the square root of 2 by the product rule becomes the square root of 6 over 2. Because again, this right here is the square root of 4, or 2. Now this one is simplified already because this is not 6 here, it's the square root of 6. So we are finished. Now problem 3 requires us first to think about how to better simplify this radical before we rationalize it. So to simplify a radical, I need to think about what square goes into 24. So I'm going to say negative 15 over the square root of 4 times 6, because 4 is a perfect square. So it's always best to first simplify your radicals before you try to clear them from the denominator. So the square root of 4 is 2, and the square root of 6 stays. Now the part of this that must be cleared out or rationalized is the square root of 6. So I'm going to multiply by the square root of 6 on the top and the bottom. The top becomes negative 15 square roots of 6, and the bottom, let's talk about what happens to the bottom. I'm going to tell you that it becomes 12, so let's talk about how that happens. The square root of 6 times the square root of 6 is the square root of 36, or 6. Then it's 2 times 6 for 12. Now it'd be great if we could stop right here, but 15/12 is reducible as a fraction by 3. So I need to reduce this to negative 5 square roots of 6, dividing by 3, dividing here by 3 for the number 4. So here is my reduced fraction that has now been rationalized, meaning there's no more square root in the denominator. So 4 is very similar to 3. I'm going to first think 5 over the square root of 4 times 5. I'm going to say 5 over 2 square roots of 5. Now what needs to clear is the square root of 5. So I get 5 square roots of 5 over 10. Let's play out where we get 10. This right here is the square root of 25, which is 5. And then 2 times 5 is 10. Now 5/10 reduces, so we get the square root of 5 over 2 when we reduce the fraction. Problem 5. First we're going to separate this into negative square root of 8 over the square root of 63. Then we're going to find the square in each of these, so we're going to write 4 times 2 over 9 times 7. Then we're going to clean these up. We're going to get negative 2 square roots of 2 over 3 square roots of 7. Now what has to go is the square root of 7. So we're going to multiply top and bottom by the square root of 7. So the product rule right here says these get multiplied together. So we get negative 2 square roots of 14 over this right here. When you multiply a square root by itself, the square roots always cancel for the radicand. So this is 7. 7 times 3 is 21. And that one does not reduce any further. Now we're going to throw in some variables. So the square root of w needs to be cleared out, so we multiply by the square root of w. So we get negative 5 square roots of 3w over w. Because remember, when you take a square root times itself, the square roots cancel and you're left with the radicand. 7, you may think the only thing you have to do on problem 7 is to clear out the square root of x, but the square root of 75 also needs to be simplified. So we're going to say that this is the square root of 25 times 3 over the square root of x. So this is 5 square roots of 3 over the square root of x, and then what has to clear is the square root of x, so we multiply top and bottom by the square root of x. Product rule in the top says multiply these together and keep them under a shared square root. So we get 5 square root of 3x over x, because again, when you multiply a square root by itself, they cancel and you're left with the radicand. 8 requires us first to separate the top and bottom into each of their own square roots. We get square root of 150 m to the 5th over the square root of n cubed. Now we're going to clean these, we're going to simplify these. So right here I'm going to think about 150 as 25 times 6 m to the 5th over the square root of n cubed. Now I'm going to continue simplifying my radicals. So the square root of 25 is 5. This power here is bigger than my index, so I need to divide. I need to see how many times 2 goes into 5, twice. So I get an m squared out. All that's left behind is 6m, because 5 divided by 2 would be 2 with the remainder of 1. Over the bottom, 2 into 3 is 1, with 1 left behind. Now we can't stop here because we have a square root in the denominator. So we're going to multiply top and bottom by the square root of n. And we get 5m squared square root of 6mn over n squared. So let's talk about how we get n squared. Square root of n times square root of n becomes n, because again when you multiply the square root by itself you're left with the radicand, and then n times n is n squared. So we have one more to think about here. So I am going to say that I have the square root of 162 n to the 9th over the square root of w to the 7th. I'm going to find what perfect square sits in here, so that's 81. So I get the square root of 81 times 2n to the 9th over the square root of w to the 7th. Now this becomes 9n. Now I need to figure out how many times 2 goes into 9, and that would be 4 to get me to 8, and I'm left with 2n. Divided by 2 into 7 would be 3, with 1w left behind. Now what has to be cleared is the square root of w. So I'm going to multiply the top and bottom by the square root of w. So my final answer is 9n to the 4th square root of 2nw over w to the 4th, because the square root of w times the square root of w is w, and w times w to the 3rd is w to the 4th. Now finishing up section 7.5, they're just going to ask you to look at a fraction and decide if it's in lowest terms. So we're going to simplify the radical expression, and then we're going to factor the numerator and cancel. This is a preview of some of the answers that will happen in Chapter 8. This right here is a minus sign, so let's fix that. So square root of 2 and square root of 7 don't simplify. So we're to step 2. What does the top and bottom share in common? So we need to find our common factor across the top. And I'm going to say that it's 8. So 8 would come out, and I'd have 9 square roots of 2 minus 2 square roots of 7 over 24. Now that 8 is in front, 8 24ths gets to be reduced. So 8 drops this to a 3. So I get 9 square roots of 2 minus 2 square roots of 7 all over 3. Now, these expressions are not identical, so I cannot subtract, so that's my simplified answer. Now, when I look at problem 2, I need to first think, what square goes into 180? What's the biggest perfect square? So I'm going to say 36. So 6 minus the square root of 36 times 5 over 18. Now I'm going to clean this up, so I get 6 minus 6 square roots of 5 over 18. So that was simplifying my radical. Now it says factor the numerator. So what do these terms share? They share 6. So let me take out the 6, and I get 1 minus the square root of 5 over 18. Now I can see 6/18 reduces, so 6 goes into here. 3 times. So my answer here is 1 minus the square root of 5 over 3. So a couple of more. What perfect square goes into 72? I'm going to say 16 minus 12 square roots of 36 times 2 over 24. I'm going to clean this up so I get 16. Now careful, the square root of 36 is 6. 6 needs to be multiplied with 12 for 72, so minus 72 square roots of 2 all over 24. Now I need to take out the common factor that's shared in the numerator, right, which is 8. So I'm going to take out 8 and get 2 minus 72 divided by 8 is 9 square roots of 2 all over 24. Again, 8 24ths reduces down to 3, so I get 2 minus 9 square roots of 2 over 3. It just so happens that every single time our denominator has ended up 3. That's just by happenstance, not because that's always how it will be. Final one, 2x minus the square root. I'm going to write 4 times 2x squared because I'm looking for that perfect square that sits in 8. Then I'm going to clean this up so I get 2x minus 2x square root of 2. Again, the 2 from square root of 4. And x squared can't stay. I have to take 2 into 2. All over 4x. So now what do they share? They share 2x. So I'm going to take out 2x and get 1 minus the square root of 2 over 4x. So 2x over 4x reduces. In fact, the x's go away, and 2 makes this drop to 2. So my answer is 1 minus the square root of 2 over 2.